Trevor, it's a fantastic opportunity to join you here in Coventry. Now, you're part of Coventry University, but explain what AIME is.
AIME's the Advanced Manufacturing and Engineering Centre. It's part of a set of research groups and research centres that we've got. So we've got Coventry University. Underneath that, we've obviously got all the teaching and the usual things that we do as a university and all the research. But we've also got this Institute for Future Transport and Cities, and under that sits 5 research centres, and AIME, the Advanced Manufacturing and Engineering, is one of those centres that is looking at primarily students. So we have this factory on the shop floor, which we have 3 years of students upstairs, and from those they've gone through one process already. We've now got master students from those. We have researchers based here, looking at a number of areas which I'll discuss. And then, obviously, they have their PhD students as well. We also, out of here, so we've got the teaching, we've got CPD, we have KTPs, we have a number of KTPs that are funded projects, and we also have research, and that research is either privately funded, it can be government funded, or it can be part funded through various consortiums. And most of that research is based on industry needs. So our focus in AIME is really, it's trying to address the industry problems in a practical, usable and deliverable way. So it's very much applied research. So
now that's quite interesting because you head up the metrology department here, and we all know that inspection metrology is a very important part of manufacturing, but you spend a lot of money here, and today we're here on behalf of Bruker Alicona. You've invested in this G5 metrology system, but tell us why.
Well, firstly, metrology is very important, and here and in most research areas, metrology is seen as a cross-cutting theme. So no matter what you're doing, you're probably capturing some data. You need to understand the integrity of that data, and you need some traceability on that data. So metrology is very, very important indeed. Why have we spent so much money on metrology? We do metrology for metrology's sake as well. So we're very interested in proving and looking at things, equipment such as being part of a system. So the future of manufacturing, this whole I4 drive, where everything happens within the machine, so it's a system. What we're looking at is understanding the traceability and the true traceability, calculable capability of measurement systems that can be applied in a user environment out on the shop floor, essentially. Surface texture to us is proven to be more and more important. We've done lots of research or support research into electric vehicles, so we're talking about electrical contacts, so we need to transfer energy, so we want perfectly flat faces. If you think slip gauges, we can't manufacture those things. So for us, surface textures become very, very important in terms of understanding form as well as texture, because lots of people can look at surface texture or surface form. Although one sits on top of the other, it really, until the Alicona came along, for me at least, I didn't really see anything that gave me both of those together. But not just together, but it gave me traceability and a level of confidence for me to be able to take that information and pump that back into the system. So it's now become part of our metrology system rather than a standalone piece of equipment.
And I see a lot of these systems now from Bruker Alicona, they're not just for the laboratory, they're in-process manufacturing at the end of the day, aren't they?
If you look at any measurement piece of equipment, essentially what you're looking at is a system once you introduce other things. So if you've got a small production line that needs to capture temperature, velocity, energy uses, whatever it is you're sensing, you need to be able to sense that, understand the performance of that's traceable with uncertainties. And I think something like this piece of equipment, or the optics and the capture system within this, that's sitting on the end of a robot, capturing things as they happen, as opposed to take it off the line and bring it in the lab and wait a couple of hours until you get a result. So this is part of sensing that makes up that bigger picture of I4, because it's not all dimensional.